So let's discuss this problem. Count the number of maximum bitwise OR subsets. So what this problem says is basically, so we need to find two things. One is the maximum possible bitwise OR in the whole array. So suppose we have C1, C2, C3, C4, C5. So we need to find out what's the maximum possible OR of this array. I'm just writing here max OR. And the second thing what we need to find is basically number of non-empty subsets, basically number of non-empty subsets whose value is equal to the maximum OR that we got from the first step. And once we get this number of different non-empty subsets with maximum bitwise OR, we just need to return this. So let's say number of subsets. Now how to approach this problem? At at first instance, it might seem that how we can find the maximum OR. So as we are doing OR, so we are pretty sure the maximum OR is nothing but the OR of all the elements. The OR of all the elements is the maximum OR. So C1 or C2 or C3 or likewise C5, whatever OR we get, whatever OR result we get. So this would be the maximum bitwise OR of this array. Now we need to find out number of subsets which actually matches this. Uh, Again, this is a very direct question. What we need to do is basically we just need to find out all the subsets recursively and find the and see if the OR of those subsets actually matches this result, which is a subset of the whole array. And if it matches, we just increment one counter. That's it actually. So it's very simple actually. So let's look at the code actually. So here is the code of it. So in the first step, uh, what we do is basically get the OR of all the elements, and after that, through this inner function, what we do is basically get all the subsets and see if this matches the uh, uh, or summation that we got actually, and if it matches we just increment this result counter and return this result. Now this is basically a question of how to generate subset. So first we set this function with I value 0 and or now at 0. Now when I equals to n, it means that we have all the, like basically we have found a combination of the elements, and we see if this result or now is equals to s. If it matches, then we increment the result. So how we generate subset? So increment I, and it's basically take and no take approach actually. So in the first instance, oh sorry, so in the first function call, what we do, we just take the number at I, and in the second function call, we don't take the number I, the number that is present at location I. We don't take it and just go for the initial, um, for the next recursive call. So that's how we do it actually. So 0, suppose it is 0, it is at location 0, it will call 2 1. If it at location 1, it will call 2 2. Again this will call 2 2, like this. So what's the time complexity of this? So we see for each function call we have two recursive calls. So it's basically take and no take approach. So suppose there are C1, C2, C3, C4 elements. For each of the elements, it's like take and no take. So it's like one time we take it and the other time we don't take it. So there are three possibilities. So it's 2 to the power n, where n is the number of element. So it's order of 2 to the power n. Thank you. You can refer to the description box for the lead code answer, for the lead code code. Thank you.